It's a very cool countdown. Okay. It is trig, so you do need to be able to create a unit circle. We're not going to do that right now. We'll do it in a little bit. But maybe if you're like really nervous about doing a unit circle, it's maybe a good thing to start practicing. Maybe draw one a night or something like that. Remember, there's all those tricks like 3, 2, 1, 1, 2, 3, whatever. The fist trick. If you Google it, you'll see there's a trick with your hand on how to do it. We'll go over that when we get there. We were talking about unit circle before, so everyone here's trig and thinks unit circle. Okay, let's just do some practice questions. Let's start off with more basic stuff. So, question 1. For the angle negative 120 degrees, determine the reference angle, a positive coterminal angle, a negative coterminal angle, and the general solution. That's asking for a lot. Before we jump into any of that, though, let's just remind ourselves of some basic things in trig. Like the quadrants. Yeah, that's always a tough one to get wrong. This one's quadrant 1, quadrant 2, 3, 4. Every once in a while somebody just gets it backwards, and that always hurts the heart a little bit when you just have the quadrants wrong. Okay, so you start in the top right and you go counterclockwise. Cool. On these, you need a booklet. On these quadrants, we have terminal arms, right? So it's like a line, comes out of the origin. Yeah, so if you had something like this, that'd be like our terminal arm, a little red guy. There's two ways to measure our angles to that point. You could go positive or you could go negative. To go positive for a standard position angle, you start at the positive x-axis and you go counterclockwise. That would be a positive angle. Positive standard position angle. Right? We went counterclockwise. If you go the other direction, you're doing a negative standard position angle. So I could get to that terminal arm by going from my positive x-axis and going this direction. And that would give me a negative standard position angle. I'm just going to put negative I'm just being lazy. So when you see negative angles, like that's what they're trying to tell you. They're trying to tell you the direction that you're going. If it was positive, you're going counterclockwise. Negative, you're going clockwise. So when I read this question, and I read for the angle 120 degrees, negative 120 degrees, I would sketch it like this. Start at the x-axis. You are going to go clockwise, so you're going to go down like this. And you go roughly 120 degrees. I know that if I went down to the y-axis, that would be 90 degrees. So 120 should be about halfway past that. Something like that. That's just a rough sketch, right? Like it doesn't have to be perfect. Okay, now that I've sketched that, let's determine all these things it asks for. We'll start with the reference angle. The reference angle means go from your terminal arm, that line you just drew, and go to your closest x-axis. That means this is my reference angle. That little green angle. For the record, reference angles are always positive. Okay, when we're talking about them, always positive. To figure out reference angles just kind of comes down to the situation. There's no like set way to do it, no formulas or anything like that. You just got to figure out how much do you need to get to that x-axis. So the way I would do this is I would say, well, if this is 120, I know that all the way to the x-axis would be 180. So to get to the x-axis, I'm missing 60 degrees here. So that reference angle must be 60 degrees. 60 degrees plus 120 would be 180, right? It would get me all the way there. Cool. Next thing it wants me to determine, a positive coterminal angle. To get a positive coterminal angle, you take your angle and add 360 degrees. You just do one full spin. So I got negative 120 plus 360 degrees, and that will tell me what my positive coterminal angle is. In this case, it's 240 degrees. That means if you went back to your graph and you drew a standard position of 240, it would get you to the same spot. So that purple thing right there, that is 240 degrees. We call it coterminal because it gets you to the same spot. Right? It gets me to that same arm. It's positive because of the direction it went. For the record, you could get as many coterminal angles as you want. Just add another 360, and it'll give you another angle that gets you to the same spot. If I want a negative coterminal angle, I take my angle and I subtract 360 degrees. So basically, I just do another spin, but backwards. For this question, that would be negative 120 degrees, and I'm just going to subtract 360 degrees to give me negative 480 degrees. Looking at my graph, that means if I started on my x-axis and I went backwards 480, so I'd do a full backwards 360, keep going, that would be 480. There's my negative spin. There's my negative another 120 to give me negative 480. They're all called coterminal because they get you to the same spot, right? Do you mind just pulling that door shut? She might be done talking, but it's just loud. Thank you. Okay, and the last thing, which proved to be a struggle on our unit exam, throwback to trigonometry unit exam, we forgot what the general solution was. So the general solution is a way of writing all the coterminal angles. To get your general solution, you take the angle you're starting with, so in this case it's negative 120 degrees, and you add a spin, like a full rotation, which would be plus 360 degrees. That would give you one coterminal angle. We want all the coterminal angles, so we multiply that 360 by n, where n has to be an integer, meaning n has to be a whole number, positive or negative. If I want to do backward spins, it would be negative 1, negative 2, negative 3, whatever. If I want to do positive spins, it would be positive 1, positive 2, positive 3. And you could do all the solutions. That gives you all the coterminal angles. This is referred to as your general solution. Because it provides all coterminal angles. You do typically see a question that asks about that at some point. It says, like, solve this, and now give the general solution. Right? So find the angle, and then tell me what all the coterminal angles would be to get to that point. Cool. With degrees, it's usually not so bad. Then we learned what radians were, right? And it's just another way of measuring angles. It's like talking centimeters and inches, right? It's like a different, I was gonna say, it's like a different system. That's not. It's just a different type of unit, right? It's still measuring the same thing, just a different unit. So now we're gonna switch things up to radians. This one says sketch the angle 5 pi over 6 in standard position. Okay. Bless me. Sketching radians. 5 pi over 6 is on your unit circle. If it's something that you like happen to remember or memorize, awesome. They could give you anything though. They could say 5 pi over 18, and that's not on your unit circle. And you'd be expected to understand how to sketch that. Okay, when you're doing radians, you're going to start over here at 0 radians. And remember that 180 degrees is pi radians. So this, I'm going to erase it in a second, so don't write it down. This would be 1 pi. Right, that angle. Cool. What they've done is they've taken pi and they've divided it by 6. Right, so you've got 6 pieces of pi essentially. So what you can imagine they've done is they've taken that 1 pi, which was this, and they've split it into 6. So it'd be like 1, 2, 3, 4, 5, 6. Remember I used to like draw in here. I'd be like, here, 1 piece of pi, 2 pi, 3 pi, 4 pi, 5 pieces of pi, 6 pieces of pi. So if I want to do 5 pi over 6, then the angle that I'm looking for, this would be 1 pi out of 6. This would be 2 pi out of 6. 3 pi over 6. 4 pi over 6. 5 pi over 6. That's the angle I'm talking about. So I'm sketching it out to about close. Here. I'm calling this 5 pi out of 6. Had it been 6 pi out of 6, it would have been all the way here. It would have been 1 full pi. That's how I like to do radian measurements. That way if they do throw something weird at me, like, hey, I want to sketch 3 pi out of 7. I'm like, that's not on my unit circle, and I don't freak out. I just know, oh, okay, they divided it into 7s, I want 3. And I can kind of rough estimate where it would be. Okay, determine the reference angle. Reference angle. You're going to the closest x-axis. Reference angle is right here. Same way that I was looking at my angles and I was like, okay, what would complete 180? Now I'm saying, what would complete 1 pi? Like how much is missing here so that I can go all the way to pi? If this was 5 pi out of 6, I'm only missing 1 piece of pi. That's 1 pi out of 6 right there. Pi out of 6. That's your reference angle. If we want the general solution, we're going to follow the same pattern we did for the last question. We're going to take our original angle, which is 5 pi out of 6. And we are going to add a full spin. I'm not going to put 360 degrees though, because I'm talking radians. A full spin in radians would be 2 pi. And if 1 pi only got me to 180, 2 pi would get me to 360. And just like the other general solution, I multiply that by n, and I say that n is an element of the integers, meaning it has to be a whole number, positive or negative. No decimals allowed. If n was a decimal, I didn't do a full spin, and I didn't get back to that same terminal arm. Right? So that's why it has to be element of I. Yes, sir?
If you did that in degrees, like you just turned the radian into a degree, would the general solution still be correct if you wrote it out like that?
Oh, I don't think so.
Okay.
I think if they give you a question, a written response question in radians, they expect an answer in radians. Numeric response, multiple choice, for sure they expect it to stay in radians. Yeah. Yep. If you did all your work in degrees, figured out the general solution in degrees, then converted your answer back to radians, that would work. You're doing a couple extra conversions that you probably don't need to add that stress to yourself. But if that works for you, it works for you. Yeah.
Are we supposed to keep changing our calculator with our radians and everything?
Yeah. Yeah. Anytime you're doing a radian question, it needs to be in radians. Anytime you're doing a degree question, it needs to be in degrees. Honestly, it's in radians a lot. But yeah, you do want to make sure your calculator's in the right mode for each question. It only affects trig. All right? Sometimes people come out and be like, I think I got perms and columns wrong because my calculator's in the wrong mode. It doesn't matter. It's only if you use sine, cos, tan. It's the only time the mode matters, is if you use one of those 3 buttons.
And when they reset our calculators, does it go back to radians?
I believe it defaults to radian mode. Yeah. Okay. Number 3. An angle in radians that is coterminal with 30 degrees is. Okay. Coterminal. Means I'm just doing spins. I'm either adding or subtracting. Okay? They gave me 30 degrees. All the answers are in radians. So we got to do a conversion here. We got to convert this.